Okay, so helium has 2 protons because the number on top of the box for helium is 2. Yes. We will be doing notebook checks at the end of the unit. All right, so let's go on to the next part. That's pretty easy. For the electrons, okay, just remember the protons and the electrons are going to be the same. So if you have 2 protons, you have 2 electrons. Okay, so super easy. Protons and electrons are going to be equal. Okay, I think today's the last day. You guys can assume that. After today, it's going to be a different, but I'll let you guys know how to calculate all that later. Okay, and then last but not least, we have neutrons. Well, to find neutrons, if you guys remember, this number back here is the mass number, and this number is protons plus neutrons. So if you want to find just the neutrons, you just do the mass number minus the protons. So 3 minus 2 is 1. So you have a total of 1 neutron. Okay, so that's how you get the numbers. This is what we learned last time about isotopes and the neutrons and whatnot. Just wanted to review how to do it before we go into today's new material. Okay, but any questions on how to find protons, neutrons, electrons? Okay, all right, let's draw it now. So remember, protons and neutrons go in the middle of the atom. So we're going to draw 2 circles with a plus sign. We're going to draw 1 circle with nothing inside of it because that's the neutrons. And then we're going to draw 2 electrons flying around, and they don't touch anything. They're not in contact with even each other. All right, and there you go. That's going to be what a helium-3 atom looks like. Okay, and again, this is review from last class. But we'll need some of the same skills in order to learn the new material today. Any questions on this problem? Hopefully it's not too bad. Alrighty, if you guys have not already, make sure you guys title the lecture notes. It's called Electron Shells. It's written on the top, and that's what your assignment is going to be called today. Again, you will need your periodic table, so just make sure you guys have that out because we are going to be using it a lot. All right, let's get started then. So for the next part, there's a lot of writing, but I'll tell you guys what's important to write down. A lot of it is just information you guys just need to make a mental note of. But again, don't copy everything down. There's a lot of text, and I'll explain what you need to write down. All right. So we've talked about what atoms look like, right? Protons and neutrons go in the middle, and the electrons, they fly around the nucleus. Okay, now, one thing you guys need to know about the electrons is that electrons, they're not like planets that go around the sun in these nice orbitals or shapes. Okay, if we kind of visualize what it looks like in reality, electrons kind of do something like this. And they fly around, and they kind of go in this random pattern. Okay, now, we call this the electron cloud. You guys don't need to remember that, just so you guys know. But it's an easy way to think about how the electrons are moving. They like to move in between these layers. But obviously, that's very complicated and undrawable. And so in order for us to kind of better conceptualize how the electrons move around in the atom, we draw them in terms of electron shells. Now, these shells are not real. Okay, again, they don't move around the center of the atom like planets. Okay, they move around kind of sporadically, but there are areas that the electrons spend more time in, and that's what these shells are. So that's what we're going to be learning how to draw today. Okay, so let's learn how to draw these shell models. So don't copy these all down at one time. We're going to go step by step, solving 2 problems. I'm going to show you guys how to draw these shell models. The first one you do need to copy down is this right here. Okay, number 1, instead of drawing the middle or the nucleus of the atom, now we just write the symbol, okay? So instead of drawing like 2 protons and 1 neutron, we just write He in the middle, and that's going to represent the nucleus. So a little bit easier, but make sure you guys copy this first rule down. Instead of drawing the nucleus, we just write the symbol of the element, okay? Okay, so instead of drawing the nucleus with all the protons, all the neutrons, we just write the symbol. Just go one at a time. Right now, write down number 1. Okay, so again, you're not going to draw the nucleus anymore. You just need to write the symbol. So if we are going to draw the shell model for number 1 for helium, you know how we just drew the 2 protons and everything, right? Instead of doing that, we just write He. So on your paper somewhere, you guys can mark down number 1 and then He. Okay, so we're going to be writing these rules down as we do the problem. I think it's the best way to learn it. It's just easier. Okay, so again, first rule, we don't draw the protons and whatnot. We just draw the symbol, okay? Which is nice because today we're going to be looking at bigger atoms. And if you look down on the periodic table, some of them have like 100 protons. And you don't want to draw 100 circles. We don't have time to do that. All right, let's look at the next row. The next rule is the number of shells that an element has, it's equal to the row number. And I'll show you guys what that means in a second, but I want you guys to write this down. The number of shells an element has depends on which row it is on the periodic table. Okay, the number of shells an element has depends on its row number. All right, so let's take a look at the periodic table, and I'm going to show you guys what I mean by the shells equal to the row number, okay? So if you guys look at the periodic table, I'm going to zoom out. And you guys will notice there, the periodic table is organized into these nice sections. Now, if you guys just remember from regular vocabulary, rows go side to side. So this is row 1, this is row 2, row 3, so on and so forth, right? So what this means is, depending on which row the element is on, that's how many shells it has. So if we're looking at the example that we are doing right now, helium. Okay. Helium is in the first row, right? That means it has 1 shell. Okay, if we look at, for example, carbon. Carbon's in the second row. How many shells does carbon have? 2. If we look at aluminum in the third row, how many shells does it have? Yeah, so on and so forth. Okay, pretty easy, right? So we are going to continue doing number 1. So number 1, we're looking at helium right here. Number 1 is helium. Helium is going to have 1 shell. So what we do is we just draw 1 circle, 1 shell around helium. Okay, so the periodic table is really nice because it organizes a lot of information for you. Depending on which row the element is in, that tells you how many shells it has. All right, and then the last one for this problem is number 3. You guys don't need to copy this one down. This is just pretty easy to remember. The number of electrons an atom has is equal to the atomic number. So if you remember helium, if we look at helium on the periodic table, we just said the number of protons, or the atomic number, is 2, right? That means that helium has 2 electrons. So what we're going to do is, for number 1, we're going to write down 2 electrons. Helium has 2 electrons. So we just need to draw 2 electrons in that shell. And there you go. That's pretty much what helium looks like. You got the center, and you got 2 electrons flying around. All right, any questions on that one? Hopefully it's not too bad. Again, the only new information we really learned is the row number. Okay? Elements, depending on what row it's in, it tells you how many shells there are. Okay, let's try number 2. I'll have you guys do the first part of number 2. So we're gonna write that. We're gonna do number 2, which is carbon. I'll do it right here. I'll do it in blue. Okay, I want you guys to write C for carbon, and on your paper, I want you guys to draw how many shells carbon has. Okay, so just go on your periodic table, find carbon, and write down how many shells carbon has. If you want to do the electrons, you guys can do the electrons as well. You'll be skipping a step, but we'll get to that. Yeah, I'll show you guys how to split them up. All right, so hopefully you guys found carbon. And if you guys notice, carbon is right here in the second row, right? So it's going to have 2 shells. And the number for carbon is 6. So carbon is going to have 6 electrons. So let's write that down somewhere. Carbon has 2 shells, and it has 6 electrons. Okay. Any questions on that part? Yeah, we're going to be drawing it. So we're going to draw 2 shells around the carbon. And now what we do is we need to add the electrons. Okay, now, this one's a little bit different because now there's 2 shells, right? So we got to figure out where the electrons go. And that's where this rule comes in right here, number 4. Okay, and I want you guys to write this down. The maximum number of electrons in a shell is equal to the boxes in that row. So write that down. Might sound a little confusing, but I'll show you guys what I mean in a second. The maximum electrons that go in a shell is equal to the boxes in that row. Okay? Just jot that down somewhere. So again, make sure you guys copy that down. Maximum electrons in a shell is the boxes in that row. Okay. And if you're done copying that down, go to the periodic table for me because we're going to be looking at that again. Alrighty, guys. So let's talk about what rule number 4 means. So we're going to look at the periodic table, and I'm going to zoom out again. All right, so if you guys take a look at carbon, you guys told me that carbon is in the second row, so it has 2 shells, right? So carbon is going to be in the second row, so it has 2 shells. Now, we have to put the electrons in the correct shell. So let's take a look at the rows. So if you guys look at row number 1, how many boxes are in row number 1? 2, good. So if you look at row 1, there are 2 boxes. Okay, what that means is we can put a maximum of 2 electrons in the first shell. Okay, so in the shell number 1, since there are 2 boxes in row 1, we can have 2 electrons max. That's the maximum capacity of the first shell. Okay, so that means that since carbon has 6 electrons, we're going to draw 1, 2 electrons in the first shell, and now the first shell is completely filled up. Okay. Okay, but we still have 4 electrons, right? So we just put them in the second shell now. So we put 2 in the first shell, then we go 1, 2, 3, 4. You can do it on your notes. I'm just doing it here so we can look at the periodic table. Okay, but you should have 2 electrons in the first shell and then 4 in the second shell, and that'll give you a total of 6. Okay? Yes.
Couldn't you also put all 6 on the second shell?
You cannot, yeah, because that's where the next rule is. I'll bring it back up, but you have to start inside out. Yeah. Mm-hmm. It's not. All right. So that's going to be what carbon's shell model looks like. Now, before we move on to the next example, I'm going to have you guys try it on your own. I want you guys to take a look at the second row. If you guys take a look at the second row, there are 1, 2, 3, 4, 5, 6, 7, 8 electrons. What that means is shell number 2 can have a total of 8 electrons max. Okay? And if you look at shell number 3, it's also 8, so it can hold 8 max. You look at the next one, is 18, so on and so forth. Okay, so just keep in mind the maximum number of electrons in the shell depends on how many boxes there are. Okay, and we always start inside out.
You write that all down.
You don't have to. You can keep that in mind. All right, do you guys think you could try one on your own? Yeah. Okay, so I will leave the rules up here for you guys to take a look at, but I want you guys to try number 3. I'll put number 3 right here. Number 3, you're going to be drawing the shell model for sulfur. Okay, so take a second. You can work with the person next to you or try it on your own. I want you guys to draw the shell model for sulfur. And I'll put the 2 examples we did down here so you guys can keep an eye on it, okay? I want you guys to draw the shell model for sulfur. 3? Okay, so we are looking at sulfur. So if you see sulfur, how many shells does sulfur have? 3, yeah, and it has 16 electrons. Good. So sulfur is going to have 3 shells. Okay, so 1, 2, and 3. And there are 16 electrons. Okay. I apologize for my bad drawings. All right.
They're really good.
I appreciate that. Okay. So we are going to plug in the electrons now. If you guys remember, there are 2 boxes in the first row, right? That means we can put 2 in the first shell. If you guys look at the second row, there are 8 boxes, right? So that means that we can put a maximum of 8 inside of the second shell.
8 electrons.
8 electrons. So 2 in the first shell. So 2 electrons in the first shell. Okay, and then 8 electrons in the second shell. Everybody good with that? Yeah. Yeah, so the number of electrons in the shell depends how many boxes are in that row. So the first row is the first shell, right? So there's 2 boxes in the first row. So the first shell can hold 2. There's 8 boxes in the second row. So that's the second shell. Second shell can hold 8. Yeah, or that's the maximum capacity. So it's 16. So we drew 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. We need to draw 6 more. And then 6 in the third, exactly. 1, so 11, 12, 13, 14, 15, and 16.
So why do you have to separate it like that?
Oh, we just draw them in the cardinal directions, up, down, left, right, so it's easier to count. Yeah.
Oh.
Yeah.
So you don't have to fill, like, you don't have to do as much as in each row, but you can figure out. I'm so down.
Alrighty, guys. So again, instead of drawing the big shell structures, right? If there's multiple shells, we draw something called a Lewis structure. Okay. So let's talk about what a Lewis structure is. It's where you draw only the valence electrons. Now, I want you guys to write this part down as well. The valence electrons are the electrons on the outermost shell. So copy that down. Valence electrons are electrons on the outermost shell. Okay. So take a second to copy that down. I'll explain what that means. Okay. Valence electrons are the electrons on the outermost shell.
Right, what else?
The highlighted part. Valence electrons. So take a second to copy that down, and after that, we're going to look at the example we just did. Okay, so in Lewis structures, we only draw the valence electrons, and those are the ones on the outermost shell. All right, so let's talk about what that means. So if you guys look back at the example we just did, we just drew sulfur, right? There's 3 shells, and even for sulfur, you're starting to notice this is kind of tedious to draw, right? The structures are bigger, there's a lot of dots. So we draw these Lewis structures. So this right here is called a shell model. Okay, but now we're gonna do a Lewis structure. And in a Lewis structure, we only draw the electrons on the outermost shell or the valence shell. So if you guys take a look on the outside shell of how many electrons are there? 6. So when we draw the Lewis structure for the shell model, all we do is we write S, and then we just draw 6 dots, and that's it. Okay, this is the same thing as this. Okay, a lot easier to draw. What's up?
Write down the portion highlighted.
Yes.
Wait. How do you do that?
So in a Lewis structure, we only draw the valence or the outside electrons. So there's 6 electrons on the outside shell. So we just draw the 6 electrons. That easy. Yeah.
That's easy.
Easy peasy, right?
Oh, you don't even draw the circle.
You don't even draw the circle. All right, so I'm going to teach you guys how to figure this out very quickly instead of drawing the shell and figuring everything out. But any questions on what a Lewis structure is? Again, it's just Just draw the valence electrons. Okay, so let's do a quick example. Okay. There are some rules. I just want you to write this part down. The first rule is, and you don't even need to write down the full rule, just copy down, you count the boxes in the row. Okay, I'll explain what that means, but I want you guys to write down, you count the boxes in the row. Okay, so Lewis structure. Yes.
So if like the shape, the structure, like what if you know like how are you supposed to know that that's a certain amount of
That's what we're about to get into. Yeah. How many electrons are in the valence shell, right? Yeah, that's what we're going to talk about. Okay, so again, just copy down the first part of the rule. You count the boxes in the row. Very easy. Okay, so let's go back to our example of sulfur, and then I'm gonna show you guys what that count the boxes thing means. So let's go to the periodic table. Okay, if we take a look at sulfur on the periodic table, we said sulfur is right here in the third row, right? Now, how many valence electrons did we say sulfur has?
6.
6. So we just said that there's 6 valence electrons. And a very easy way to do that is we just count the boxes in the same row until we get to that element. So sulfur is right here. So let's count the boxes. Box number 1, 2, 3, 4, 5, 6. And that's how you know how many valence electrons sulfur has. You literally just count the boxes until you get them. That's it. Very easy. All right, so let's talk about that example with barium real quick. Yeah.
So the one example, you had the shell almost next to each other. Were you comparing both the shells?
Yeah.
Or both, sorry.
Yeah, they're the same thing. Yeah, both sulfur. Yeah. All right, so let's do the one for barium, okay? So if you look at barium, remember, that's the one that we just talked about. There's 6 shells. It's humongous. But if you want to draw the Lewis structure, we just count the boxes. Barium is box number 1, 2. So all we got to do is put 2 dots next to barium, and we're done. That's the Lewis structure for barium. Easy peasy, right? Thank you, Lewis. Saved our lives. Thank you. Alrighty, easy peasy, right, guys? Okay, so we have one more rule, and then we'll be all done. So the last rule is, let's do an example. We're gonna look at bromine, Br. Okay, Br is right over here on the periodic table, number 35. Now, if you guys take a look at bromine, it's all the way on the right side, right? So we're gonna count the boxes. We're gonna go 1, 2. Okay, but I want you guys to write this on your periodic table. You see this section, groups 3 through 12, right? This whole section right here, I want you guys to just write down, you skip this section when it comes to the valence electrons. If you want to know why, we'll talk about it later, but we talk about this in AP chemistry. So if you want to learn why, for whatever reason, you can take AP Chem and I'll teach you why. But we skip these groups 3 through 12. And then we pick up where we left off. So 1, 2, 3, 4, 5, 6, 7. This is honors chemistry. Okay, so bromine has 7 valence electrons. Junior year. Yeah. Yes.
What happens if you get an element that's in between that?
It's different. You won't. Yeah, yeah. Again, that's only for AP chemistry. Yeah, you guys don't need to worry about that. All right, and that's Lewis structures and valence electrons. Any questions?
So you skip all the way down until like the last shell or row?
Yeah, you skip 3 through 12 until you get there.
So you go all the way from like if you would draw down to like would it be there where your cursor is to you skip?
So like
there.
No, the shells matter. So this guy right here, number 23, still has 4 shells. Yeah, but we're not going to be looking at these ones.
But you don't skip it, or you skip it, but
You skip it for the valence electrons, not for the shells.
For like 21 through 112, you just skip those?
So we skip this when it comes to valence electrons, so counting the dots, but you can still count the shells. This one's like this one right here still has 5 shells.
Oh, so you just won't put the number?
Yeah, it's for only the valence. Okay, before we finish up, we're gonna use the bromine example to go over one last part. Shh. Okay, so if you take a look at bromine on your periodic table, how many shells does it have? Bromine, right here. 4. It has 4 shells. Okay, and again, shells is because of the row. Okay, so if you want to write this down, just to clarify, put everything together that we learned today. The shells is dependent on the row. So if we're looking at bromine, which is right over here. Okay, bromine is right here. The rows tell you how many shells it has. Okay? Okay, let me ask you guys now. How many protons does bromine have? 35, and that's the number on top of the box. Okay, so we're gonna put the atomic number. Okay. How many electrons in total does it have? How many total electrons? 35. 35 because remember, protons and total electrons are the same. Okay, so jot this down. This will be helpful for your assignment. Okay, and then last but not least, okay, so we talked about protons, and total electrons. How many valence electrons does it have? 7. Yes. 7 electrons, 7 valence because those are the ones on the outside. You just count the boxes in that row. Yeah.
What does it mean by like 4 shells equal a row?
Oh, I'm just telling you, find the shells by counting the rows. Because bromine is in row number 1, 2, 3, 4.
So
Going down.
there's
4 shells, exactly.
But you don't draw the
You only draw the shells for the shell model, not the Lewis.
Yeah, you don't draw them for the Lewis.
All right, any questions? That was just kind of to bring everything together. Yeah. Valence electrons are the electrons on the outside shell. That's where you count the boxes until you get to that element in that row. Because you skip the middle section. Yeah, so 1, 2, skip, 3, 4, 5, 6, 7. Yes. All right, so
Do we write this down too?
if you want to, it'll be helpful for your assignment.